the beginning, when the universe that we know today came into being, there was an explosion. In the first fractions of the first second, what had been a complete vacuum began to evolve into what we know now as the universe. It was tremendously hot, with primordial particles of matter and antimatter rushing around in all directions. As the universe expanded further and cooled, common particles began to form. These particles were to become the building blocks of matter as we know it. A few minutes after the explosion, the first elements formed, while the universe kept expanding. At some point in time, stars and galaxies were born, but it would take another 9 billion years before our Sun and Earth came into being. The story of our universe is the most dramatic one can tell. It is a story that is put together piece by piece, not by great novelists and playwrights, but by scientists, geologists, biologists, physicists, and astronomers. When did the first stars form? When did the first galaxies form? What was the chemical composition and how has it evolved? What did the early universe look like? How can we learn about events, however dramatic, that happened many billions of years ago? One place to search for answers is located in one of the most pristine landscapes on Earth, the Altiplano of the Andes, a landscape of serene beauty straddling the borders of Chile, Bolivia, and Argentina. Here, on the Chilean side, scientists have found a site for an astronomical observatory that will provide new insights into some of these fundamental questions. The site is called Llano de Chajnantor, a plateau 5,100 meters above the sea, looking down on the charming village of San Pedro de Atacama and looking up at the magnificent southern sky. In a few years, Chajnantor will be the home of the largest collection of astronomical telescopes in the world, operated in a unique, almost global collaboration between Europe, North America, Japan, and Chile. The ALMA project, a truly giant array of telescopes. With ALMA, astronomers will study electromagnetic radiation in the millimeter and submillimeter domain, coming from some of the most distant objects in the cosmos, unlocking a wealth of information about the earliest epoch of the universe. ALMA is still some years away, but already now, scientists are starting to observe from the unique Chajnantor site in this precise radiation domain, using APEX, the Atacama Pathfinder experiment. APEX is operated in Chile by ESO, Europe's intergovernmental astronomy organization, with funding from the Onsala Space Observatory in Sweden, the Max Planck Institute for Radio Astronomy in Germany, and ESO. APEX is a modified ALMA prototype antenna, operating in the southern hemisphere. The collecting surface has a diameter of 12 meters. It has been adjusted to an accuracy of 17 microns, less than 1/5 of a human hair, all across the surface and at all times and positions. No small feat, given the harsh environmental conditions at 5,100 meters. The telescope, or antenna, as some astronomers prefer to call it, is equipped with a small suite of advanced instruments to capture and analyze the radiation from the sky. For its first observations, APEX is equipped with state-of-the-art submillimeter instruments developed and built by the Max Planck Institute for Radio Astronomy and by Chalmers University of Technology. The data is relayed by means of a microwave link to the APEX base just outside of San Pedro de Atacama. This is also the site from where the telescope is controlled during sky observations. APEX has already begun its scientific life on its lonely high-altitude site. Some of the radiation that Apex will detect was generated billions of years ago. It arrives to us as silent messages from a time when the first galaxies came into being. Looking at distant galaxies is but one of the many areas of science where Apex can make a unique contribution. Another one is the study of star and planet formation in the Milky Way. New stars are born deep inside clouds of dust and gas. Like a cocoon, the dust keeps the new members of the cosmic family out of sight, hard to observe with telescopes designed for visual light. But millimeter and submillimeter radiation penetrates the clouds and provides us with a unique view of the stellar nursery and the processes that go on. Apex will, among other things, be used for comprehensive surveys of the galactic plane, which will mark the places that ALMA will study in minute detail. As a real Pathfinder, Apex will clear the way for ALMA. But it is also an outstanding scientific facility in its own right, and an important tool for the scientists in their never-ending quest for understanding the world in which we live.